So this video we're going to look at exponential equations and instruction to logs. Exponential equations and logs are related because, well, exponential equations lead to logarithms. Logarithms are actually an exponential part of an equation. Yeah, really an equation or expression, I guess. So what is an exponential equation? So an exponential equation is something like 2 to the x equals 4. It's called an exponential equation because your x is in the exponent. Okay, and some of these are pretty darn easy to solve. If I have 2 to the x equals 4, hopefully I can just look at that and say, well, x is 2 because 2 squared gives me 4. If for some reason you don't see that right away, you could say, well, 4 is the same thing as 2 squared. My bases are the same, then, well, x had to equal 2 in order for this to be true. Same thing with 3 to the x equals 27. I should be able to just look at that and say 3 to the what gives me 27? Well, 3 cubed gives me 27, so x has to equal 3. So those are exponential equations where you have x in the exponent. And some of them, as I said, are pretty easy to solve. Some of them are pretty impossible to solve in your head. If you have something like 5 to the x equals 7, I can't look at that and know what x is. I can't say, well, 5 to the 1.23873 whatever is 7. I just don't know that. And it's not a perfect 5 to the power. Like if it was 5 to the x equals 25, I could probably do it. Well, I could do it. But 5 to the x equals 7, So this is where logs came in. They said, okay, well, we like to have x equaling something. We don't like to have x in the exponent. It's weird. If x equals something, then I at least could start tables. I could sub it into something else. And there were old logarithm tables back in the day. So they made up a new word. They made up a word called logarithm. I should know who they is. I kind of forget right now. And they said, okay, log is going to enter when my x or whatever equals log was in the exponent. And my base was 5, so I'm going to call this log base 5 of 7. So the way to read a log is saying, well, 5 to the what gives me 7. Okay, so when you see log, it means that that base, what would that base be raised to give you whatever's in the log? So let's do this a few more times. So this is called logarithmic form. So this right here would be logarithmic form. This would be exponential. Okay. So if I have something like 6 to the x equals 8, I don't know. I don't know 6 to what power is going to give me 8. But I want to know what x equals, so I'm going to say my x was in the exponent, so I'm going to write a log to show that it was in the exponent. My base was 6, so I'm going to write base 6 of 8. And again, this reads 6 raised to what power gave me 8. That's what my x is 6 to what power is 8. So if I do 7 to the x equals 10, I want to write in logarithmic. I'm going to say x equals log base 7 of 10. And it reads like that, log base 7 of 10. Okay, if I have log in logarithmic form, I can see if I can simplify. So if I have log base 2 of 4, again, this reads 2 raised to what power gives me 4. So log base 2 of 4 would actually just be 2. 2 raised to the second power gives me 4. Log base 3 of 7 would read 3 raised to what power gives me 7. I don't know, so I might as well just leave it like this. This would not be simplifiable because I don't actually know. If I had log base 3 of 9, that would be 3 raised to what power gives me 9. That would equal 2. Hold on, my cat has... There, okay. So hopefully that makes a little bit more sense. So what this means is, again, logs are the exponent part, 2 raised to what power. So properties of logs follow properties of exponents. Logs and exponents are pretty much the same thing. So if I'm multiplying things inside logs, so if I have log of x times y, When I multiply common bases, what do I do to the exponents? I add them. So this would be the same thing as log of x plus y. It follows again exponents. If I have x squared times x to the 3, that would be x to the 5. I add the exponents. Okay, so if I have log of x over y, what do I do when I divide common bases? What do I do to the exponents? I subtract them. So, same thing. I'm going to subtract, and I'm going to write log after every one, because that's what indicates it's in the exponent. So log of x minus log of y. And if I have log of something raised to a power, well, what do I do when I have exponents raised to a power? I'll make that 3 so it's a little different. So like x squared, whole thing cubed, I multiply them. So here I'm going to take my power, bring it down, and multiply it times my log times the exponent. So a log of x. So these go both ways. If you are going from a single log, and that's what this is a single log. You're going from a single log and you're expanding, then you can just use your properties of exponents. If you're going expanding to a single log, you're just going backwards. Okay, so let's look at 2 or 3 real quick and see if we can get a little bit of shortcuts in here. So say we have log base 3 of 5x. So here, all the ones in the practice were just log. If you just have log, that is the same thing as log base 10. It's kind of like when you have a square root, you know that there's a little tiny 2 in there, you just don't have to write it. When you just see log, that's log base 10. Okay, so it doesn't matter though if we change the base, we're still using the same properties. So if I have log base 3 of 5x, that's 5 times x. So I'm going to expand this to be log base 3 of 5 plus log base 3 of x. Okay, so if I have log base, let's say 7 of 5x over 2, I can say, okay, my 5 and my x are being multiplied, so I'm going to write that as log base 7 of 5 plus log base 7 of x. My 2 is being divided, so I'm going to say minus, if I divide, I'm subtracting exponents, so log base 7 of 2. Okay, let's do one more. Say I have, just stick with log real quick, of 3x squared over 5y to 7. I can say my 3 and my x squared are being multiplied, so I'm going to have log of 3 plus log of x squared. My 5 and my y to 7 are being multiplied, so I could write that as log of 5 plus log of y to 7. But my multiplication of 5 to y 7, my product, is being subtracted. So I need to make sure I subtract and distribute it through both parts. So I'm actually subtracting that log of y to 7. So now I can bring down the exponents and write it as log of 3 plus 2 log of x minus log of 5 minus 7 log of y. Okay, we'll work on this a little bit more in the next one.